Okay, let's solve mini quiz 8.5. This entire mini quiz mainly tests our ability to convert between exponential equations and logarithmic ones. And the thing to remember here before we even start is just a basic way of doing that. If I have, for example, 2 to the power of 3 equals 8, this is an exponential function. If I want to convert this to and from a logarithmic function, my logarithmic function, right, will have the same base as the exponential, log base 2, okay? And then the inputs and outputs switch. So here's the input for this exponential, and here's the output. So those are going to switch places, right? So the input of my logarithm will be 8, and my output will be 3. Log base 2 of 8 equals 3. So we want to notice, where did the 2 go? The 2 stayed in the base. It was once the base of the exponential. Now it's the base of the logarithm, and I can do it the other way as well. Meanwhile, the exponent eventually landed on its own. The 3 became isolated, and the 8 went into the logarithm. Okay, so if I can just remember how to do this, I should be good. Let's use that as an example to find our first equation. Log base 3 of 27 equals p. Where's that 3 going to go? Well, the 3 is in the base of the logarithm, right? So the 3 is going to be the new base of my exponential. And what is going to be that exponent? Is it the 27 or the p? Let's try to take a look. So here on the right, the base was 2, so the base became 2, and the 3 on the other side became my new exponent. Okay, so that p is going to become my new exponent, and then that equals 27. I could also, of course, write the equation the other way around. It's exactly the same thing, right? And what is P? Well, I could just look at this and think, well, what 3 to the power of what equals 27? But if I can't do that in my head, and you could probably do that in your head, but if you can't, then you can always just go to the calculator and try it. Log base 3 of 27 is P. So what is log base 27 of 3? Well, I'll go to my math menu, go up to log base, try that, put in 3 on the base there, put 27 on the input, hit enter, and I see that the answer is 3. Ah, yes, and that makes sense, right? Because 3 to the power of 3 is 27, right? Okay. So similarly, if I want to convert this to an exponential, right, that 5 will remain in the base, and now my exponent is 34, and my m is now standing alone. Ah, well, now my variable is solved, so let's put that in. 5 to the power of 24. It's probably going to be pretty big. It's 5 times itself 34 times, but nothing our calculator can't handle. 5 to the 34. Oh, that's a pretty big number. It's 5.82 times 10 to the 23, which is about the number, not far off the number of particles in a mole of a substance, you know? So 5.82 times 10 to the power of 23, that's in scientific notation. So 5.82 times 10 to the power of 23. That's what the little e means. Finally, log base z, or z, of 6 is equal to 1. So that converted becomes z to the power of 1 equals 6. And I think it's pretty easy to see what z must be, because z to the power of 1 is just z, so z equals 6. Okay. Let's move on and go the other way. We're going to take a bunch of exponentials and write them as logs. Okay. So 3 to the power of x equals 19, which means log base 3. And where does this x go? Does the x go on its own, or does it go inside the logarithm? It's going to go out here. Sorry, it's going to go out here. There's my x, and the 19 will go inside. Okay, so again, just by looking at our conversion, this is worth memorizing. This thing is worth memorizing. Absolutely worth memorizing. Okay, so converting between those two is really important. Log base 3 of 19, that's not like a nice clean power. We're going to have to use our calculator. Luckily, it's pretty easy, and I can even just use my We'll bring here. So instead of 27, let's do 19, I believe it was. Log base 3 of 19 is 2.68. Great. No problem. 2.68. How about 4 to the power of n equals 256? How can I change this to a logarithmic equation? Again, the 4 is going to remain the base of my logarithm. So log base 4 of 256 equals n. Okay, so log base 4 of 256. Let's just try that here. For 256, throw that in 4. Ah, makes sense because 4 to the power of 4 is 256. Not bad. And how about this? 5 to the power of 2x plus 1 equals 100. Okay, so I have to notice here that 2x plus 1 is inside of my exponent. All right, 2x plus 1 is inside of my exponent. So it's already ready to convert. Now I'm going to run through a couple of examples after this to show where we may not be immediately ready to convert, but here we can, okay? If I raise 5 to the, or if I take a log base 5 of both powers or both sides, I'll get log base 5 of 2x plus 1, sorry, log base 5 of 100 equals 2x plus 1. Okay, and now I have to solve this. I can't just immediately solve this, but luckily log base 5 of 100 is just a number. Okay, so there, log base 5 of 100. I don't know what it is off the top of my head. 2.86. 2.86. Okay, so that's not so bad. So this number ends up being 2.86, and we can solve that. 2.86 equals 2x plus 1. So I'll subtract 1 from both sides to get 1.86. And then I'll divide both sides by 2 and get x equals 0.93. And that's the end of my mini quiz. Now I want to run through just 2 more like example problems that require an extra step, okay? So this wasn't on the mini quiz, but it's still important to know for the test. Let's say, for example, that we have 2 times 3 to the power of x equals 17. And what if I wanted to solve for x? Solve for x. Am I ready to just take a logarithm already? All right, so do I do a log base 3? Log, because 3 is in the base? Well, not yet. Not yet. I can't do that yet because this 2 is still in there. Okay? Because what I'm really doing is I want to take logarithm of both sides, right? What I want to do is log base 3 of the entire left side and then log base 3 of the entire right side. That's what I'm really doing by doing this operation. When I convert between an exponential and a logarithm in this way, what I'm really doing is either taking a logarithm of both sides or I'm raising a number to the power of both sides. Okay, so I'm not yet ready to logarithm. Instead, what I need to do is divide both sides by 2. Let's divide both sides by 2. Okay, now I have 3 to the power of x on the left, and 17 divided by 2 is 8.5. Okay, now I'm ready to try my logarithm conversion. Whoops. Okay, I can now do log base 3 of 8.5 equals x. So only when I have something to the power equals something am I ready to convert? Okay, now I can throw this into my calculator, which I'm just going to do off screen here, assuming you know how to do it. We'll say that log base 3 of 8.5 is 1.948. Okay. The same thing applies in the other direction. Okay. So if I have, for instance, a problem like this, let's say log base 2 of x plus 1 minus 7 equals 3. Okay. Log base 2 of x plus 1 minus 7 equals 3. Am I ready to just turn this into an exponential? Do I do 2 to the power of this and 2 to the power of this? Well, I can, but it would be a lot easier to get rid of that 7 first, because remember, I'm taking 2 to the power of the entire thing. Okay. Instead, what I want to do before converting is make sure that the log or the exponent stands alone. So instead, what I'll do is I'll add 7 to both sides to get log 2, x plus 1. I'm treating this entire thing like just a term, which it is, equals 10. Now I'm ready to convert. Okay. So this 2 will become the base of the exponent, and I'll get x plus 1 equals 2 to the power of 10, right? So this 2 becomes the base of this exponential. Well, 2 to the power of 10 is 1,024. So if x plus 1 equals 1,024, then x itself must equal 1,023. So make sure that you are clear on which steps to perform first when you are solving logarithmic or exponential equations.